Today's lesson is lesson 6.2, quadratic formula with real solutions. Today we're going to learn how to solve quadratic equations using the quadratic formula. This formula is quite helpful when the quadratic function or the quadratic equation is unfactorable. The quadratic formula may be used to solve any quadratic equation, however. The quadratic formula states that in a quadratic equation ax squared plus bx plus c is equal to 0 has a solution at x equals negative b plus or minus the square root b squared minus 4ac all over 2a. If the solution of a quadratic equation results in the square root of a negative value, the equation will for now have no real solution. When you get to Algebra 2, you will learn that this gives what is called an imaginary solution, but that's for Algebra 2. All right, so the first thing I need to do is I need to make sure that I have my equation set equal to 0. So they have given us an equation here in the process, and they've gone ahead and set it equal to 0. We're going to identify our A, our B, and our C values from our equation, and then we're going to plug them into the formula. Once again, this formula right here. And then we're going to go ahead and simplify. Notice that we're doing the discriminant, the part under the square root first. Then we're going to go ahead and rationalize the square root. And then we're going to go ahead and simplify as much as possible. This is what is called an exact answer, and these are my two approximate answers from my calculator. Why are there two answers? Because of this guy right here. This is a plus and a minus, meaning that one time they did 1 plus the square root of 106 and divided that all by 7. And then the next time they did 1 minus the square root of 106 and divided it all by 7. So they just went ahead and did this twice in the calculator. Let's go ahead and practice. All right, solve using the quadratic formula. So let's go ahead and zoom in here to example A. The first thing we're going to do is draw our line to see if it is equal to 0. I do not see a 0 on either side, but I do see that the x squared is over here on the right side. However, it is a negative, so I'm going to go ahead and move it over here. So I'm going to take both of these and move them to this side with the 12x. Remember, I can do this at the same time by simply canceling them out. Nothing over here should combine together. However, sometimes it does. So I'm just going to take my time. All right, I want to make sure that I'm in standard form, which means I'm going to find my x squared term and I'm going to put it first. There is nothing to combine with it, so it is just a positive x squared. So I'm just going to put x squared. Then I'm going to find the x term. There is nothing to add with it because this one's already been moved. So I'm going to go, it's a positive 12x. I'm going to go plus 12. And last is my minus 42. Now I have it equal to 0. Now I can go ahead and I can identify my A term. Remember, my A term is right here with my x squared term. So my A, since it is not there, it is the invisible 1. My B term is going to be right here with the x, and remember to take the sign with it. This is a positive 12 for my B. And lastly, my C term will be right here after the x. Remember to take the sign because this is a negative 42. Yes, it matters. Now I'm going to go ahead and I'm going to grab my formula from up above, and I'm going to go ahead and I'm going to make what I call a skeleton. I'm going to get everything ready for my substitution. Anytime I see an A, a B, or a C, I'm going to go ahead and put parentheses. Now, to help me even more, I could go back to the worked example and I could say that my A's go here, my B's should go there, and this is the only place to place my C. So now I know that this is 1 and this is 1, 12 and 12, and then negative 42. Now I'm going to go ahead and I'm going to grab my calculator. And at first, the only thing I'm going to do is I'm going to do it in chunks. So I'm going to take this part right here and I'm going to say, is it positive 12 or is it negative 12? Well, to become a positive 12, I would have to see two separate, I would have to see two negative signs. I only see one negative sign. Remember, I'm only focusing right here. So it is a negative 12. Then I'm going to come on and put the discriminant, which is all this stuff between these two parentheses. So I'm going to put negative 12 squared minus 4 times 1 times negative 42. I am not putting the square root. Notice I wrote it down on my paper. And I'm going to put 312, and 2 times 1 is 2. Okay, that's the first thing I'm going to do. Now I'm going to go ahead and I'm going to take my 312 and I'm going to do the prime factorization. So I'm going to take 312 and I'm going to start dividing it by prime numbers. 2, 3, 5, 7, 11, 13, but those are probably the ones that are most commonly used. Honestly, I just start dividing by 2 until I can't divide by 2 anymore. I wanted that to be square. There we go. I can keep dividing by 2 because I keep getting an even number. And then 39. Oh, I could divide 39 by 3, can't I? 13. There we go. So the rule is, as I prime factor, I can put the numbers on the outside right here. These are my primes. I can put them together in groups of 2 because we're doing a square root. So these two 2's get to come out of the square root. But the 2, the 3, and the 13 have to stay. So I need to do 2 times 3 times 13, which should be 78 because that's this number right here inside the box. All right, so I should have as my prime factorization negative 12 plus and minus. The 2 comes out, square root 78 divided by 2. Now what I'm going to do is I'm going to divide each of these by 2. I'm going to take the negative 12 and divide it by 2 separately, and then I'm going to take the 2 and divide it by 2 separately. So negative 12 divided by 2 gives me negative 6, plus or minus 2 divided by 2 is 1, the square root of 78. This is my exact answer. So when you go into Delta Math, sometimes they ask for the exact answer, and this is it. To do the approximate, I'm going to do negative 6 plus the square root of 78 in the calculator, and then I'm going to do negative 6 minus the square root of 78 in the calculator. And I'm going to get my two decimals, and I'm going to round them to whatever decimal spot Delta Math asks me to. So make sure that you read. They like to put it in italicized. And this would be, of course, my approximate answer. Okay, let's give it one more try here with part B. Now, as I draw my line, I notice for part B that everything is already set equal to 0. So I can go ahead and say that A is the 1/2. B is going to be the negative 9. And C is going to be the negative 25. And remember, I just got that from the standard form of my quadratic, which is this right here. A is always the number in front of x squared, B is always the value in front of x, and C is always the constant at the end. Just like before, I'm going to go ahead and make my skeleton, set it all up. The color helps me. If it doesn't help you, then by no means do you have to use it. However, I just find it very easy to say, okay, the blue one goes there, the two purples go here because they're the B's, and the pink one goes here because they're the A's. I can also come in and just put it in that color for you as well. There we go. All right, so remember once again, we're going to do this in stages. So the first thing we're going to do is we're going to look right here. Is it positive 9 or is it negative 9? There are two negatives, so this one is going to change to a positive 9. Then I'm going to get my square root ready. I'm going to start right here and I'm going to go to right here. I am going to ignore the square root. So it's negative 9 squared minus 4 times 1/2 times negative 25. That's what I'm going to put into my calculator and I get 131. No, I do not. Hold on 1 second. No, I do not. All right, hold on 1 second here. 4 times 0.5 times 25. 81 minus 50. Oh, no, yes, I do get 131. Sorry, I do get 131. It's 81 plus 50. Yes, I do get 131. Sorry about that. Because 2 times 1/2 on the bottom is 1. Since 2 times 1/2 is 1, I can come back and I can erase this. Okay, that's what was confusing me. So I'm going to leave it for right now, but really I just have positive 9 plus or minus the square root of 131. There we go. Um, I'm going to try to break down 131, but I do believe it is prime. So this would be my exact answer. This would be my exact answer if that's what Delta Math is asking for. And my approximation, once again, remember it's 9 plus the square root of 131. And then it's 9 minus the square root of 131. That's what this thing right here means. You've got to split it into two different answers. So 20.446 and negative 2.446. These would be my approximate answers. And then, of course, remember rounding applies to that depending on what Delta Math is asking you. All right. Now we could go ahead and we can do this in a word problem situation, a real world situation. So now my function is going to represent the height in meters of a ball launched upwards from the surface of the Earth's moon, where t represents the time in seconds. So here in part A, they want us to once again go ahead and use the quadratic formula to determine when the ball reaches the ground. Remember, all you have to do is replace this h of t, your y value, with 0, and I can see that I'm already in standard form. My a value is going to be that negative 0.8 in front of the t squared. My b value is going to be the positive 5 in front of this t, and there is not a constant, so it is going to be 0. Now I'm going to go ahead and I'm going to plug into the formula just like before. Oops. Let me make that look a little nicer. And once again, let me just show you with the color. The B's go here. The A's go next to the 4 and the 2. That's how I remember it. And then the C goes last. So I always remember it that there's only one C. The B's go first, the A's go next to the numbers 4 and 2, and then C just takes in the last and final spot. Now, if I am very careful, could I put this all in my calculator at once? Yes, but it just depends on what kind of answer Delta Math or the test is asking you. Okay, so there's my discriminant. Remember, all this stuff under here is the discriminant, and this is what I'm putting in the calculator first, and I'm ignoring the square root. Oops, there we go. Negative 1.6. I know the square root of 25 is 5, so I have negative 5 plus 5 over negative 1.6. Now, this one would not be left in an exact answer due to the fact that the square root has disappeared. So this one should only have a decimal answer because on the top, I know what negative 5 plus 5 is, it's 0, and I know what negative 5 minus 5 is, it's negative 10. So I'm going to go ahead and split them to do my my approximate. So one answer is 0 and the other answer would be 6.25, right? Remember this was negative 5 plus 5 divided by negative 1.6, and this was negative 5 minus 5 divided by negative 1.6. That's how I got those two answers. Due to this problem situation, this is my only answer. 0 does not make sense in this situation. Okay, 0 does not make sense in the situation because why would it land back at 0, right? If I were to graph it, I could put a point here at 0, right? Because remember, my solutions are my zeros, are my x-intercepts. And then I can go to 1, 2, 3, 4, 5, 6, and maybe just a little bit more. I'm not quite sure where the vertex is, but I do know that it is downwards facing like this because my A value is negative. Okay. In the last one, determine the reasonable domain. Remember, the domain are your X values. Oops. There we go. The domain are my X values. So I'm going to use my two solutions. I'm going to use my two solutions. It's going to go from 0, hold on a second, from 0 less than or equal. I'm going to change it from X to T because we just use T instead to 6.25. Okay. At 0 seconds, the ball is launched at 0 seconds and it hits the ground at 6.25 seconds. So that's what that is the meaning. That is it. That explains its meaning. So we launch it. This is the launch. This is the launch of the ball. And this is when it hits the ground. This is when it comes back and it hits the ground. All right, I do encourage you to pause the video and give this last one a try. It's asking pretty much the same type of thing. A ball is launched upwards from a platform 7 meters above the ground on Earth, and T represents the time in seconds. So I do encourage you to pause the video and to solve this one as well. All right, hopefully you went ahead and you got the correct A, B, and C. Hopefully you went ahead and remembered that the B's go here, the A's go next to the 4 and the 2, and C fills in our last and final spot. Okay, remember going in steps is key simply because you never know what the test is going to ask, right? What is the assignment going to ask of you? Now, something like this, because I did get 162.2 as my discriminant, this one is going to go into a decimal mode. So could I have just put the whole thing in? Yes. Okay. So if you take some time and read, you can save yourself some time while doing it. There are my two solutions. Remember, this is the one where I did negative 5 plus the square root divided by the negative 9.8. And this is where I did negative 5 minus the square root of 162.2 divided by the negative 9.8. Now, in this scenario, This one does not make sense. It is a solution to the quadratic function, but because this has a scenario in the real world, this one doesn't make sense, and so this would be my final answer. Um, Graphing wise, remember those are your x-intercepts, so something like this, and then something like that, and then it's going to do something like this. There we go. Right? I don't know exactly how high up it's going to go. Well, it did say something about a 7, um, so it's probably going to go a little bit higher, but that's okay. Right? If I really wanted to see what it looks like, I could put it into the calculator, the original equation, to see what it really truly looks like. My domain, remember my domain are my x values. Remember my domain are my x values. So I'm going to go ahead and I'm going to use my answer from right up above. Those are the numbers I'm going to use. No, wait, but the negative one doesn't make sense. So I'm going to replace the negative with 0 because that would be the time, right, that I am going to launch the ball at. So once again, we're launching, right? We're launching here at 0 seconds, and we're going to hit the ground after 1.810 seconds. All right, there is a try this at the end of the lesson. Go ahead and give it a try. They're asking you to use the quadratic formula, and then they're asking you to solve it by factoring to check your work. What that means to me is that when you use the quadratic formula, you should get 2 whole numbers for your answer, and those are going to help you to do your factoring.